Over here we have some definitions. The first is the definition of PNR, which is the number of ordered sets with R elements taken from a set with N elements, and the definition of CNR, which is the exact same except if you notice the word order is removed. So what does that mean? How are these things actually different? Well, if you think back to what we know about permutations, we said that we use a permutation when in our problem none of the elements can be repeated, and when either the order matters or we've also thought about that as different roles. So let's see what happens for combinations. So if I'm picking a set of R elements from a set of N elements, remember a set can't have repeats in it. So it's also true that for a combination, we can't have repeats. On the other hand, the order matters for a permutation. But remember, when we just write down a set, it doesn't matter the order in which the elements are listed. If you think back to our first example, it doesn't matter whether I gave the 2 tickets to Fred and then Scott, or Scott and then Fred. So the order did not matter at all. So for a combination, you just need to have that there are no repeats. The order should not matter, or all the roles should be the same when you're going to apply a combination. So let's look at a couple of problems and let's decide whether we're going to use a permutation or a combination. So let's say in a race there's 10 people, and the top 3 finishers will advance to the next round. And how many different groups could advance? So in this scenario, if you're running this race, it doesn't matter to you whether you're first or second or third, because you're just going to go to the next round and run again against some more people. So here, the order of the finish doesn't matter at all. You could be first, you could be second, you could be third. The same thing happens to you. Of course, we can't have repeats. The same person can't finish first and second, for example. So we're in a combination situation because, again, no repeats, but the order does not matter. So this one would be C10-3 because we have 10 people and 3 of them will advance to the next round. Now, in a race with 10 people, in how many ways could we award gold, silver, and bronze? Now, this becomes a permutation problem because the order matters. If I'm first, I get gold, but if I'm third, I get bronze. So there's a difference based on what position you finish in the top 3, whereas here there wasn't. And of course, the same person can't win both gold and silver. So again, there are no repeats. So for this problem, it would be P10-3. And just to get practice, let's actually compute some of these numbers. So remember, for a permutation, it's you can do it either using the formula, or if you just remember, you start at this number and you use that many. 10 times 9 times 8, or 720. And then let's also figure out the combination up here. So C10-3. So we could go back to the formula. So the formula says it's n factorial over n minus r factorial times r factorial, which in this case, 10 factorial over 7 factorial times 3 factorial. And then we could write these out. So the 10 factorial starts at 10 and goes all the way down to 1. The 7 factorial starts at 7 and goes all the way down to 1. So a lot of those will cancel from the 7 and beyond. So we'll have 10 times 9 times 8. That's the 10 factorial over the 7 factorial. And then we have to divide by the 3 factorial. And you can plug this into a calculator or continue to reduce, and regardless, you will get that the answer is 120. So that's the difference between a combination and a permutation.